Hello and welcome to C++ Club. This is meeting 172 and today is the 30th of May 2024. A bit of feedback. Robert wrote to me, you quote a prediction regarding regulation on software engineering and then ridicule it with a laughing track like we were watching a sitcom. This was really undignified. Oh boy. Especially since I assess the prediction to have some truth to it. It's already starting to happen. Customers start putting pressure on software developers to follow rules and fulfill regulatory requirements, so they won't be liable if the software they bought causes damages. End quote. Having worked as a consultant in many large firms over the years, I've seen things. Code written by contractors who don't give two shits about the quality of code they write. Current place being a rare exception. The entire defective and badly designed systems produced by outsourced programmers, ruining people's lives, like the UK Post Office defective Horizon system produced by Fujitsu, where software bugs were ignored and covered up. I'll put a link in the notes. Have a read. This has been happening for many years and it is still happening. And just wait for the onslaught of AI-generated code containing subtle bugs. So forgive me if I'm not too optimistic here. Now, one correction. A Redditor wrote to me regarding regarding my Swift remark. They say, it is straight there in Apple's official documentation and 2023 talks by Apple employees. Quote, Swift is a successor to the C, C++, and Objective-C languages. It includes low-level primitives such as types, flow control, and operators. It also provides object-oriented features such as classes, protocols, and generics, giving Cocoa and Cocoa Touch developers the performance and power they demand. End quote. I stand corrected. Apparently, Apple treats Swift as a successor to Objective-C and C and C++. And good for them. I like Swift. It's a great language to work with. Right. I wanted to briefly go back to the previously discussed White House report on memory safety. I had some quotes gathered that we didn't have a chance to discuss, to see before. So in that document, there's this paragraph, quote, while formal methods have been studied for decades, the deployment remains limited. Further innovation in approaches to make formal methods widely accessible is vital to accelerate their broad adoption. And to that, one commenter says, well, gosh, I applied to US research programs with an interest in formal methods and was rejected absolutely across the board. Good luck to you, end quote. So, good in theory, but in practice might be complicated, I guess. And also another Redditor said, this is in comment to Bjarne's response to the White House paper. This Redditor says, quote, I've been in the industry long enough to know that there's a significant number of devs that will refuse to adopt new language standards. I'm 100% confident there are C++ devs still writing C++ 03 style code, both before they simply haven't taken the time to know what's in C++ 11 and later, and because they have some mistrust and even irrational fears about enabling C++ 11 and later feature sets on their code bases. I dealt and still deal with these devs in the Java context all the time. End quote.
I couldn't disagree with that. I've seen them too. They're a major problem. And you have to remember as a statement, you said that they don't have time to learn. Quite often, the learning and introduction of new things are not encouraged in sort of over-rushed development shops.
Yeah. There's even a sort of a movement called Orthodox C++, which promotes writing C++ or 3 style code without any C++ 11 and later features at all. The main proponent is a game developer, so that figures. But
sounds like a little bit like John Carmack, who suggests to use C++, but not basically using most of the features, just pointers, not even references.
Oh, does he? I didn't know that about him.
Why don't just program in C?
Well, you do get probably namespaces and other things. I don't know if you use templates. Maybe not.
Probably unlikely. He's probably stuck on the style he used for Doom. Was Doom
You mean
C++?
assembly? Oh no, it was
Yeah,
C
I don't know.
and assembly and a lot of nifty tricks.
Yeah. There's a video. Who did it? They ported Doom to C++ in the span of a single live stream
Was
video.
it Jason Turner?
Yes, that was him. Yep. So yeah, that was cool. Yeah, and I recently had someone say to my, it was a code review, and I was like, you can use, what was there? Range for loop here instead of an old style loop. And to that, I got this reply that said something like, I'm an old man. I learned C++ long ago, and I don't have time for new things. So let's just leave it at that, or something like that. So yeah.
Yeah, you know the Sean Parent's presentation, C++ seasoning, the famous "this is a rotate" presentation.
Oh yeah.
So there's a variant of that when he tells an after story. So the example code that he simplified was in Chromium, and it's still in there because the changes that he proposed to make a 50-line code into a 3-line code was rejected by the senior reviewer, saying that nobody knows what rotate does.
Oh my.
And it's still there. I checked the Chromium repo and it's still there.
I'm guessing as far as modern C++ goes, Chromium is a really bad example. Right. There's been several safety-related articles. One of them was Herb Sutter's post titled C++ Safety in Context. It's pretty long, and all the things that he says are very sensible. But I can't shake the feeling that in the background, in his mind, CPP front is like hovering as a solution to all of this. At the end, he says, quote, "Please don't be distracted by that CPP front uses an experimental alternate syntax for C++. That's because I'm additionally trying to see if we can reach a second orthogonal goal to make the C++ language itself simpler and eliminate the need to teach 90% of the C++ guidance literature related to language complexity and quirks. This essays language safety improvements are orthogonal to that, however, and can be applied equally to today's C++ syntax." End quote. Yes, to be fair, his CPP front experiment, he uses it as a vehicle for trying out new things that can be applied to the standard C++, so it's fine. However, this Redditor commented on this article, quote, "It's unfortunate that Mr. Sutter still throws C and C++ into one bucket and then concludes that bounds checking is a problem that we have. This data really needs to be split into 3 categories: C, C++ as written by people that will never progress beyond C++ 98, and C++ as written by people that use modern tools to begin with. The first 2 groups should be considered as being outside the target audience for any kind of safety." Yeah, end quote. Next article by Lucian, Radu, Teodorescu is called Safety Revisited, and it's an absolutely massive summary of pretty much everything. Lots of links to presentations, papers and such. And he did a massive job with this post. Lots of quotes from various people involved in security and safety debate. Tons of paper links. So yeah, it's a very useful summary. It's a bit outdated, I think. Not too much outdated. So still useful, but there's like a huge list of references at the end.
So, you probably would have added this Schrambaxter talk that was about safe C++.
Definitely.
I guess, so this is an article he wrote for Overloading. Was that back in February? So
I think
was the, that was the edition
February,
before Herb brought out his safety paper, and then Herb talked about that at ACU as well. So Lucian's was a month or 2 before some newer things. It is a really useful paper. For anyone who's listening, I edit the Overload magazine. I remember reading through this and the discussion with the team about bits he'd missed, and there's so much information in there, but it's nice that he's pulled it together in one place. And like you said, now, a few months later, of course, there's more things to add, but
it's still a massively useful resource, this article. And thanks for the Overload magazine.
Magazine is great. I can also second that.
Thank you. Freely available to anyone who heads over to ACU and wants to have a look.
It's brilliant. There was another article by John titled "Looking for Pointers, the C++ Memory Safety Debate." An obligatory AI-generated image. So a couple of quotes from it. Quote, "The narrative for C++ as inherently unsafe oversimplifies the situation. The language has undergone substantial evolution, with modern iterations emphasizing safer memory practices without compromising the language's core principles of efficiency and control. The journey towards making C++ a safer language is complex and fraught with challenges. However, the discussions and proposals led by Stroustrup and supported by the broader C++ community suggest a forward path that respects the language's legacy while addressing the pressing needs of modern computing. By balancing the need for safety with the realities of existing infrastructure, C++ aims to continue its role as a powerful tool in the arsenal of contemporary software development, meeting the evolving demands of safety, efficiency, and interoperability." There was another quote from this article which went like this: "Right now, many of the articles about modern C++ and memory-safe C++ end up preaching to the choir. The advice doesn't reach all corners of industry, and many places in academia are stuck in their ways. If you go to small computer science programs at small schools, you will frequently find people learning C++ as C++ 98 or C++ 03, so they see C++ as C with classes and templates, or Java without garbage collection." End quote. I think that quote was from Reddit's discussion on this. So moving towards, I guess, what these papers are calling safer languages, let's have a look at Rust briefly. An interesting effort financed by Google. Google joined the Rust Foundation in 2021, and now they announced that Google has provided a grant of $1 million to the Rust Foundation to support efforts that will improve the ability of Rust code to interoperate with existing legacy C++ code base. Hint, hint, Chromium. So I guess they are exploring the interop. Having lost all hope to convert their Chrome code base to modern C++, they decided, let's just rewrite it in Rust, why not? Interop is good, by the way. I have nothing against it. And I'm sort of starting to look towards maybe learning Rust. Shock and horror could be useful. And it seems like a nice language if you don't pay attention to all the drama, which sometimes can be hard. But still, Google has this project. It's more or less internal because it's tightly coupled with their build system. And it seems a bit neglected, maybe, judging by the failing build badge. It's called Crubit, C++ Rust bidirectional interop tool. It's a bindings generator for C++ and Rust with the goal of integrating the C++ and Rust ecosystems. And they go, it's on GitHub, and they have some examples, but I don't know how advanced it is or how much of what C++ allows is carried over to the Rust side. KDAB, the company behind Qt and CMake, posted a series of articles. This is a 3-part article, Mixing C++ and Rust for Fun and Profit. It's pretty interesting. Lots of examples and lots of considerations like name mangling, data layout and stuff. So presumably they are using it or trying to use it with some view of the future integration, maybe with Qt, who knows. But these articles are appearing more and more. And speaking of another C++ successor, as we discovered, Swift. Pretty recently, they came up with an initiative for bidirectional C++ support, and it's now very advanced. It's very well documented, and you can use C++ standard library from Swift pretty transparent. You can access Swift functionality from C++. So it's a pretty advanced interop solution. It's a new feature in Swift 5.9, which was released last summer, I think. It's still not complete, but they are making great progress, which is nice to see. And this is another confirmation of the fact that you can't just abandon C++, especially if you are working with a language that is base for your operating system programming. And Doug Greger recently posted a series of articles, very detailed ones, that help learn Swift, help C++ practitioners learn Swift. And it has details of both C++ and Swift that are really interesting. So I thought I'd mention that. Another article titled "Why Rust Isn't Killing C++ by Logan Thorneloe. And his his website is called Society's Backend. I take it he is writing about C++, which is a very good name. Quote, "The internet likes to perpetuate the myth that C++ is a soon-to-be dead language. I've seen many people say not to learn C++ because Rust can do basically everything C++ can do, but is much easier to work with and almost guaranteed to be memory safe. This narrative is especially harmful for new developers who focus primarily on what languages they should gain experience in. This causes them to write off C++, which I think is a huge mistake because it is actually one of the best languages for new developers to learn." End quote. Moving swiftly on, I was fascinated to discover this article by Rust Foundation team that said that in their report, 20% of Rust crates, which is like library distribution units, use unsafe keyword. This is like 20% of all the publicly available Rust code. So it shows how difficult it is to sometimes use Rust without how do I put it? From what I've seen, the Rust bounce checker sometimes can be very tricky to work with. And apparently some people just revert to using unsafe things instead of maybe jumping through hoops of the bounce check, of the borrow checker.
I think they could argue that the use of unsafe in some crates, or 20% of the crates, is somewhat unavoidable and confines that use to what should be very well-reviewed code. Then again, it also proves that there is a need of unsafe somewhere at least.
Yeah. So this long article was posted by Log Games Developer Studio. And it's titled "Leaving Rust Game Dev After 3 Years." And it's a very detailed account of their gripes with Rust. But there was one quote that caught my attention, which sounded familiar and not exactly limited to the context of Rust. Quote, "Learning Rust is an interesting experience because while many things initially feel like this is a special problem only I am having, later one realizes that there's a few fundamental patterns that are universal and that everyone learning has to rediscover and internalize in order to be productive. There is an overwhelming force in the Rust community that when anyone mentions they're having problems with Rust, the language, on a fundamental level, the answer is, you just don't get it yet. I promise, once you get good enough, things will make sense. So the problem you're having is only a problem because you haven't tried hard enough." End quote.
You've noticed I'm quiet because basically I'm not very interested in language wars. But there's one thing I learned a long time ago when I thought that C++ programmers were so much smarter and so much nicer than other communities I knew. And I realized that a small, coherent community is nicer and better informed than a large community. But when a community grows towards a large number, you get the law of large numbers, which is that the average is the industry average. And so it's fairly easy to do really, really well in a group of 10,000. Try that with a group of 1 million, and you get all of the problems that people are used to from large communities and languages with large communities. It's unavoidable. We couldn't educate educators fast enough with C++, hence some of the problems we see. And the same will happen to any language that actually starts getting a real scale. The enthusiasts are doing well. And when you get 1 million users, you have a different set of problems.
Yes, yeah. Yeah, someone asked on Reddit, why all the hate for C++? And the first reply was, the vast majority of opinions that people espouse relate to their need to justify their decisions and should be of no interest to you. They are not trying to help you, they are trying to help themselves. Carry on. Good. So, finally, C++. We had a couple of mailings since the last time, and I wanted to look at some of the papers. Right, this is P3166, Static Exception Specifications. So is that the static exception effort only rewritten? I see throw specifiers, adding throw specifiers to function declarations. So this paper, quote, this paper has the following main goals: eliminate the performance-related reasons for not using exceptions in embedded and other performance-critical code, and so on, basically related to all the gripes people have with exceptions. So there was a paper with static exceptions before. I think this is like a rehashing of the same one. Louis Baker, I think he's been involved in error handling, and wasn't he the one who wrote a boost library for error handling without exceptions not too long ago? Anyway, it's interesting that I thought that static exceptions effort died out, but apparently not. Related to contracts, this paper by Gaby dos Reis, P2900 may be minimal, but it is not viable. And this is related to the contract's minimum viable proposal. This is a pretty serious objection. He says, without adequate limitation on undefined behavior in the evaluation of contract assertions, Microsoft considers the contract's facility not viable in the contemporary environments where C++ is used. Contracts facility that fails to adequately support efficient use with virtual functions and pointer to functions is woefully inadequate and unready for prime use, and the inclusion in C++26 in particular. Microsoft recommends against the inclusion of P2900 in C++26. Microsoft recommends against this proposal without applications in the standard library, in particular in the algorithm section and field experience, end quote. So that was the pretty serious objection that other papers even quoted. Interestingly, without naming Microsoft or Gaby dos Reis, I saw a quote that went like, one vendor expressed pretty serious objections to this. like as if Microsoft is a name not to be something not to be named or something.
It's usually not a bright idea to disregard what Gabby says.
Yes. So some other papers from more recent mailing are P3274, a framework for profiles development by Bjarne Stroustrup, which outlines, quote, "This document outlines a structured framework for developing and implementing safety profiles in ISO standard C++. It addresses the industry's urgent need for improved safety and the challenges of standardization," end quote. So yeah, it's a pretty thorough explanation of the motivation behind profiles. Verification, explanation what happens during verification, like there are three groups that any analysis would put any analyzed code in: verified safe for that particular definition of safe, for that particular profile, verified unsafe, and verified possibly unsafe, which could mean that it's too complex to classify.
That section, by the way, is trying to address the discussion about how about removing a lot of the bugs, even though we can't get all of them. We have to aim for a perfect guarantee for a particular safety guarantee, or should we be happy by some approximation? The answer is not trivial. My answer is we have to aim for completeness, but we have to leave something open so that we can approximate that ideal. It might take a couple of months or a couple of years to get to it, but we mustn't undermine people's confidence in the general framework by having something that almost works. I remember when type checking of function arguments were not complete, as several people suggested at the time, and my initial implementation says you only got it if you actually asked for it. And people got absolutely paranoid because they learned that type bugs of that kind didn't exist in C++. And when they hit one, they were totally confused, totally dismayed. And after I've lived with that for a few months, it was then enforced, even though it was the major incompatibility with C and basically made every C program in not C++. But it was that important. I was willing to take 100% hit on C compatibility for old C programs.
Right. So then the document goes into annotations, and the syntax is used, the ISO standard attribute syntax, like enclosed in between double square brackets, profiles, : enable, parenthesis, name of the profile. In another paper, I saw someone proposed using the @ character for this, like @enable ranges, for example, because @ is like a valid character now, and why not use it for something really big?
More seriously, Ville Wutzelainen was suggesting that it was important to have a syntax that made sure that if you fed something with profiles to, say, a C++ 23 compiler, that it would not compile. And so the key thing is, would you be able to use programs in profiles in programs that was actually written in an environment where C++17 was the corporate standard? And my answer to that is yes, we should. And Ville's answer was no, we shouldn't. So it's a real issue.
Interesting. I see some familiar code from your Flats repository, the expect function template, which I must admit I made use of very successfully. It's like at the time I thought it was like a contract check for people without contracts.
If you don't have contracts, or if contracts aren't what you can use, this is something that you can use in a particular project or organization. I'm not sure how it will work as part of standard.
Right.
And I say so.
So then the document goes into the actual profiles with descriptions and all kinds of details about each of them. And the profiles discussed are type, arithmetic, concurrency, ranges, pointers, algorithms, initialization, casting, invalidation, RAII, union. Yeah, that's it.
So this paper was meant to be about 2 pages, but people kept asking me for more details, and I hope by now it has grown not so large that people won't read it, which was what happened to some of my earlier papers because they were too long, but that it gives enough concrete stuff so that people can work on it. This is a big project, and we have to be able to work on parts of it, not the whole. And so I hope we get to the point where each profile or profile fragment can be worked on in isolation. And I'm trying to partition the problems so that we can have separate.
So the next paper I wanted to look at was this P3100. And that is Undefined and Erroneous Behavior is a Contract Violation by Timo Dumler, Gasper Ajman, and Joshua Byrne. And this is an interesting thing that they say, quote, in this paper, we propose to specify undefined behavior that manifests at runtime to be a contract violation. Our proposed framework replaces the concept of erroneous behavior and paves the way for a safer and more secure C++ standard. As we will show in this paper, the semantics provided by erroneous behavior are essentially a subset of the semantics that the contracts framework provides. We can therefore entirely subsume erroneous behavior into contract violation handling. End quote. That's an interesting take, I thought. So, does that make C++ safety and UB handling dependent on contracts? Contracts was like an opt-in feature, right?
Also, contracts have now been under discussion for maybe 10 years.
Yeah, exactly.
See when we'll get it. I doubt we'll get it in 26.
And with this paper, we seem to get automatic implicit contracts everywhere, including in places where you might not want to use contracts. I'm not sure if I like this one, especially given, yeah, exactly how contentious the contracts feature is in the committee.
We have to do something about unspecified behavior, undefined behavior. But I see a certain urgency in doing something about it.
Right. So erroneous behavior was already accepted into the standard, as far as I can remember. And now this paper proposes to scrap that and instead say that it's all being handled by contracts. Another contracts paper was written by Ville Voutilainen. It's P3338, an alternate proposal for naming contract semantics. It's probably, at the first glance, it's not like a super critical thing, bike shedding, naming stuff, but there's a but.
I think it was pointing out that this mailing and the papers in it is about a week old. And I did a quick count. There's about 130 papers, which I ought to understand before the meeting in just under a month's time. It is hard to keep up on all of this. And some of these papers seems to address fairly deep problems. You can't even be sure whether the problems are deep just from looking at summaries, and you can't see if the solutions would work without going deep into them. This is a lot of work.
Yeah, totally. So Ville says, quote, "The current naming of contract semantics more or less follows the form something something, the trueness of a predicate, and we use the words ignore, enforce, observe, and ostensibly quick enforce for the blank. This proposal suggests that we should use the form a contract violation is treated as, and that we use the words ignored, enforced, observed, and erroneous." So that's one part of the paper. But now look at this. It's like an Uno reverse card for the previous paper. The more significant part, let me find where. Oh yeah. The more significant part proposed here is that a contract with the where a contract violation causes instant termination without calling a violation handler is simply treated as erroneous behavior, with the fallback defined behavior being called the violation handler. The previous paper says, let's treat erroneous behavior as a contract violation. And this one says, no, let's treat a contract violation like an erroneous behavior. It's very, very...
There's a school of philosophy that says all deep problems in philosophy comes down to understanding and misunderstanding of terminology.
Right. So, yeah, I'm
very
curious.
Popular 30s, I believe.
Really curious how this will pan out in the committee. There was an update to the contracts paper, P29. The notable updates were addition of the quick enforce evaluation. Quote, if a contract violation is identified at runtime, the observe semantic will invoke the contract violation handler. If the contract violation handler returns normally, program execution will continue from the point of evaluation of the contract assertion. The enforce semantic will invoke the contract violation handler. If the contract violation handler returns normally, the program is terminated in an implementation-defined fashion. And this is the new addition. The quick enforce semantic will not invoke the contract violation handler, but instead immediately terminate the program in an implementation-defined. And in the meantime, there was quite a big activity around contracts. Like, for example, this paper by Peter Bindels, C++ contracts, and basically this paper is not required for the MVP. It defines behavior for a currently ill-formed construct. Basically, the MVP says you can't have contracts on coroutines, and this paper says how you would be able to do that. The next one is contract testing support, which I thought was fairly sensible, except the word magic in the abstract. Quote, "This proposal includes a few magic functions to perform only the pre or post conditions of a function given a set of function arguments." End quote. So I expect you would want to test your pre and post conditions somehow. And in the proposed example, you would have this magic function called check preconditions with some parameters to a function, and the function would be passed as a template parameter, and the check would magically happen. So technically,
I have this idea that something like contracts, you should be able to get the basics from reading one page and possibly two. If something takes 50 pages to define, probably becomes a source of errors in itself.
Well, I think that ship has sailed. Yes. The MVP is itself, how many pages? I don't know. 73.
Yes.
So the next related paper. Here we go. Ville Voutilainen writes, ship contracts in ATS. Quote, "This paper suggests that contracts should ship in a technical specification first, not in the C++26 international standard. The motivation for this is manifold. We lack implementation experience, more importantly, field experience in the form of deployment and usage experience. WG21 wide design consensus on multiple points in the proposal, cohesion in coverage, increased safety, and so on." So, yeah, he says we have had language TSs before for concepts, modules, and coroutines, and we got better features due to using a TS. And that would be also paying attention to what Gabi dos Reis says in his paper. But there's another paper titled "Do Not Ship Contracts as a TS" by Timo Dumler and John Spicer. And they naturally are trying to justify shipping contracts as an international standard instead of TS. Because according to them, contracts address an important part of the C++ safety problem. When you read this justification, it sounds almost like if we have contracts, we'll have safe C++, which is not really the case, I think. It's not some sort of automagical solution to all.
This is where you mustn't use your laugh track.
Gotcha. Then they say why a contracts TS does not help. They say a TS would not be an efficient use of time and resources because the TS process is slow and bureaucratic. To be fair, they list some outstanding issues with the contracts MVP, and it's quite a lot, actually. And given how the committee is progressing with contracts, it doesn't fill one with lots of confidence. Their position is that targeting a contract's TS would be a mistake. Now, there's another paper by Joshua Byrne, Steve Downey, and others, including John Lakers. P2900 is superior to a contracts TS. It has been proposed that the contracts should ship as a TS rather than as part of the international standard. While some technical and political concerns with P2900 need to be considered, a TS is a viable solution when only it, not existing proposals, has the potential of answering those questions. Our position is that none of the current issues fit into this category, and we strongly believe that work on evolving the contracts proposal should continue until it has consensus to be adopted into the international standard, preferably in the C++26 timeframe. But was that it? Oh no. Next one. P4000. To TS or not to TS? That is the question. By Howard Hinand, Roger Orr, Bjarne Stroustrup, David van der Voorde, and Michael Wong.
AK the direction group.
AK, sorry, didn't hear that.
The direction group.
Oh, the direction group, yeah.
So basically a bunch of people that know nothing about C++.
As some...
try that line.
So we, the direction group, recommend answer the key question. What are we hoping to learn through a TS must be clearly specified. What are the exit criteria of the TS to IS, International Standard, must be clearly specified. Use TSs for library components. Don't use TSs for a language feature unless the feature is a mostly self-contained unit. Don't use a TS simply to delay. It doesn't simplify later decision-making. Have concrete and articulated criteria for completion. So far, no TS is with. Let's see. C++26 needs contracts checking. Elchig, Matthias Kraus, Ryan McDougall, and Pez Zarif. Well, this one was pretty dramatic, I thought. Abstract, quote, contract checking is the single most important way to address C++ memory safety from C++ in a simple, easy, and backwards compatible way. The opportunity cost of not having contract checking in C++26 is too high, end quote. Well, now I'm convinced. They do mention Rust. They go into safety. Then basically they are C++26 without contract checking might as well not ship at all.
I don't think anybody would disagree with the fact that contracts would be a good thing. The problem is that there's a lot of details and that some of the definitions of contracts we've come up with, actually all of the ones we've come up with, have gotten strong opposition from some people, including me in some cases. Furthermore, there are things that you can't really do with contracts, such as I want a contract that this pointer doesn't dangle, or I want a contract that this file doesn't disappear after I have verified it is there before I use it. These are beyond simple static or runtime checks.
Yeah.
You need something further than contracts. I mean, I'm particularly interested in dangling pointers and eliminating data resource leaks.
We seem to have run out of time, but if you have 10 minutes, I would like to cover a little bit more, if that's okay. I just want to finish up with the papers. We are now switching to papers related to this paper P1306 expansion statements by Andrew Sutton, Sam Goodrick, David van de Voorde, and Dan Katz. Quote, this paper proposes a new kind of statement that enables the compile-time repetition of a statement for each element of a tuple, array, class, range, or brace-delimited list of. We seem to have had that previously in the previous reflection proposals, like code fragments or something. And this basic usage example demonstrates how you can output all elements of a tuple currently using the HANA library with HANA for each, and then how you can do that with a feature described by this proposal. And instead of HANA for each with tuple body of the loop, you would use a construct called template for. It looks like a range for. But, the container in this case is not a container but a tuple, and you iterate through all the elements of a tuple like in a normal loop.
Yeah, I haven't seen this paper. It's recent, but
yeah.
This follows up on a previous paper. I think they'll call expansions, for loops or something like that, and
yeah.
It was rather well received.
The commenters on Reddit especially are very excited by all these papers that demonstrate all the things that we can have if we have reflection, which is really nice. Like this one. Code injection with token sequences by Andrei Alexandrescu, Barry Revzin, and David van de Voorde. They explore variants of syntax that would allow you to inject code fragments into your code, like meta, not the meta programming that we know, but some kind of other higher level meta programming using reflection. I don't even know how what to call it. But it's yeah, it's really it does use the stud namespace. Actually, imagine how difficult it will be to explain to someone, once we have reflection, that template meta programming is not always related to the stud meta namespace that actually is related to reflection. So we now have like two kinds of meta things in C++. So this one was interesting. And another one is generative extensions for reflection by Andrei Alexandrescu, who, by the way, now works at NVIDIA. Go figure. Barry Revzin, Bryce Lilbuck, and Michael Garland. And this one proposes constructs like inject function, declare function, set name, set qualified name, and a bunch of other features based on reflection. I think in one of the papers, maybe even this one, yeah, somewhere in this paper, I don't know where, they sort of imply that you can inject properties into a class with the appropriate getters and setters and the underlying member variable automatically generated. And that reminded me about the metaclasses proposal that is currently was marked. It has been marked as abandoned just recently. But it may live in another form.
I mean, it does look like that, right? I remember the talk originally from ACCU, may have been 2017, where Herb Sutter presented it. And at the beginning, I think it was a bit shocking for the community to see something like that. But maybe after the time we had to digest it.
Have you noticed that lots of proposals these days seems to grow into whole programming languages in their own right?
Yeah.
That could be a problem.
Oh, by the way, there was a discussion on Reddit regarding the code injection. This is really, really cool. Expansion statements. Someone's this one, quote from Reddit. I still feel like my opinion has never changed on C++, which is that C++ really should stop trying to ship anything until epochs are in place. End quote. Talk about oversimplification.
You know, it's really easy to have a cool idea and write it up. Yeah. Making it real, making it integrated, and handling feature interaction problems is hard.
Yeah, like it was shown before that epochs are, I think you, Bjarne, said that they are impossible to implement and would result in C++ dialects.
Yes.
But on the other hand, like you said now, if every paper evolves into a programming language, we risk having done by the way of some papers.
Yeah, but not every proposal gets into the language. This is one thing that Reddit and others don't seem to understand. Most languages die, most language proposals die. So it's not real just because somebody's had an idea.
So pattern matching got mentioned, sadly, very briefly, but this paper titled A Unified Syntax for Pattern Matching and Contracts When Introducing a New Name by Ran Regev. The author says that we have two ways of introducing a new name. In pattern matching, we have, within the match statement, let X arrow, and then something that defines it, some other piece of code. And the arrow is equals greater. And in contracts, in pre and post conditions, we use ret colon and then something to do with ret, like a condition. So there are two ways of introducing a new name, and the author of this paper proposes to use let arrow.
Walter Brown wouldn't agree with this.
Exactly what I thought. Yeah, isn't arrow used for the C++? What's it called?
Implies.
Implication. Yeah, implication for C++. So yeah, and also let is a.
There's a separate proposal for introducing an implication operator, just to give a third way of using that token combination.
Would that be a separate, like, symbol or something, or combination of symbols?
But Walter Brown's paper on implication.
Right. So yeah, let seems like a not just part of the introducer, but something that has a meaning. Like it can be a let, or it can be something else. And using a combination of let and the arrow seems like maybe a bit of an overhead. But yeah, it's an interesting idea, maybe from the point of unifying the syntax. So who knows? At the very least, it reminded people about the pattern matching proposal, which is good. And this is a very curious paper by Hanna Dusikova, P3125, pointer tagging. Quote, this paper proposes a library-based design with magical functions to store and retrieve information into bits of pointers which are not significant to the pointer's address, and to inform developers about how many such bits are available, end quote. Ooh, that sounds a bit scary. She says, pointer tagging is not allowed in standard C++ as manipulating pointer bits is UB. Because of this limitation, some advanced data structures are not implementable or suboptimally implementable. This technique is an existing practice, is widely used in the field, and standardizing it would lower the bar for its safe usage among C++. And there's existing usage on different platforms for memory tagging extensions, and some other LLVM code base uses it. Yeah, there are precedents, but still, it's one of the riskier features, I would say.
That's probably why she would want to see it standardized, make it safer to play with these kind of knives. I mean, I would assume this is used in embedded a lot.
Probably.
I don't see this, luckily.
Yeah. And the final paper for today is this one. Reserve identifiers preceded by ampersand for non-ignorable annotation tokens, by Bjarne. So C++23 added the ampersand character to the basic source character set. And this paper says, outlines cases where that could be used.
Did you say ampersand or at?
At, sorry, not ampersand, sorry. It's an at symbol, the at. Thanks for noticing that, I zoned out. So yeah, one of the examples is contract annotations, where you could say at assert or at pre or at post. Trivial relocatability, like almost an attribute, but not the normal C++ attribute that we have. And
indeed, because those are ignorable, right?
Yeah. And this one is profile annotations that I mentioned. So one member suggested the syntax at enable ranges as an example of a non-ignorable syntax for enabling the ranges. It's a nice symbol. It'd be a shame to use it for just variable names, right?
Just be glad you don't have to have a well-reasoned opinion on everything here in about 4 weeks' time.
Right. So that's the papers. I think we'll end here, and I'll leave you with something funny. This is a picture. Dale Basanjo and Ivor Hewitt also suggested it to me. There's a comic panel, you know, the meme with the dinosaur talking to the audience of dinosaurs. And the dinosaur says, what's the difference between a light bulb and a programmer? And then second panel, a light bulb stops working when it burns out. Then the dinosaur cries at the end. This is us. Oh, this one I wanted to show you. Jessica writes on Mastodon, I think programming is like running a dishwasher. It always takes longer than you think, and some stuff is never as clean as you expected it to be. That's it. Thank you very much for joining, and I'll see you next time. Bye.
Thank you.